Welcome to The Explainer. Today, we're going to put on our detective hats to solve a small but honestly a pretty fascinating statistical mystery. We've got all the clues we need right in front of us, and we're going to crack this case together.
So here is our case file. A cab driver gets 10 ratings from customers, and we can see almost all of them, a 7, an 8, a 6, a 9, and so on. But take a look at the very end. There's a missing value, an X. That X is the mystery we need to solve.
So how in the world do we figure this out? I mean, at first glance, it seems impossible with just this list. But here's the thing. We have one other crucial piece of information, a single clue that is going to unlock this entire puzzle. The question is, how do we use it?
And here it is. This is our key clue. The entire case hinges on understanding this one concept, relative frequency. Now, I know it might sound a little complicated, but trust me, it's actually our secret weapon.
So what is it, really? Well, relative frequency is just a fancy way of asking, how often does something show up compared to the total? You know, if you have 10 ratings and 3 of them are a 9, the relative frequency of 9 is just 3 out of 10, or 0.30. It's that simple. It's just a proportion.
And like any good detective, we have a tool to guide us. And the formula is super simple. You just take the number of times a specific value appears, and you divide it by the total number of items in your list. This is basically the blueprint for our entire investigation.
All right, we have the puzzle and we have our clue. So it's time to start the investigation and put this concept into action. Let's see what it tells us.
We're going to follow a clear 3-step plan. It's really easy. First, we'll use our formula. Second, we'll take a close look at the evidence we already have. And third, that is going to lead us directly to our missing value. So let's get right to it.
Let's look at the facts of the case. The file tells us 2 absolutely critical things. The relative frequency for the rating 9 is 0.30, and there are 10 ratings in total. These are the 2 knowns that we're going to plug right into our formula.
Okay, so let's set up the equation. The frequency of 9, that's the thing we don't know yet, divided by the total number of ratings, which is 10, equals 0.30. So now we just need to solve for that unknown frequency.
And with a little bit of simple algebra, just multiplying 0.30 by 10, we get our answer, 3. And this is the breakthrough. This is huge. This tells us that in the complete list of 10 ratings, the number 9 must appear exactly 3 times. Not 2, not 4, exactly 3.
So now we have everything we need for the final reveal. We know our target. We need 3 9s. Let's go back to our list of evidence and see what we can actually find.
Okay, let's scan the list of ratings together. Carefully. We have a 7, an 8, a 6. There's one 9. Let's keep going, and there's the second 9. So in the data, we can actually see the number 9 shows up 2 times.
And this lays out the final piece of the puzzle perfectly. The evidence shows 2 9s, but our formula, our math, told us we need a total of 3. We're missing one.
And that leads us to the only possible conclusion. The only way to bridge that gap between the 2 9s we can see and the 3 9s we know we need is if that missing value, our mysterious X, is itself a 9.
And there it is. Case solved. X equals 9. It's the only value that makes the relative frequency of 0.30 true. It's a simple, kind of elegant solution that we found just by using one key clue.
So we solved a math problem, which is cool, but what's the bigger picture here? Why does understanding a concept like relative frequency actually matter when you're not, solving a puzzle?
Well, this simple idea is everywhere. It's the foundation for understanding survey results, customer feedback, business analytics, you name it. I mean, think about it. When a news report says 40% of people prefer brand A, that's just relative frequency. They counted up the brand A responses and divided by the total number of people they asked. It's the exact same logic we just used.
It really makes you think, doesn't it? We just found a missing piece of a story using one simple clue. It kind of leaves you wondering, what other hidden stories are just sitting right there in the data all around us, just waiting for the right question to be asked?